right, start over.
Oh, wrong one. This one.
You may want to crank it down a smidge.
Oh, is it too much?
Well, with all the ambient sound, and then because of the acoustics of this room, it's kind of echoey.
Okay, so let's fix that. Nope, wrong one. How's the manager? Volume control. There we go. Turn it down just a little bit. Okay. All right. So, getting back to multi-threading, the concept of being able to run multiple threads at the same time really kind of helps in programming, because what is happening here, you can kind of visualize it too. Okay. So the way you can visualize it is, okay, let's say you have a particular subroutine that its only job is to keep track of the location of one particular object on screen. So it has its own logic, has its own loops, and so on and so forth, its own variables, and so on and so forth. So this is what happens when it is a single thread. And then you have another one that probably keeps track of, let's say, what's happening in the background in the game, or keeping track of the score. And that thing has its own logic to specify, and it's probably its own loop as well. Okay, so it has to keep updating the screen, waiting for the score to change and stuff like that. Now, when you have multi-threading, you can have one thread for the blue part and one thread for the orange part. And for the most part, they are independent. They don't have to worry about the existence of each other or any changes to each other. And you don't have to break up the operations manually, because what you can do is to say, okay, at a certain time, after you update the location of an object, you can basically just say that I don't need to update the location constantly, because otherwise I'll be updating maybe 500 times per second, which is way faster than any screen can really keep up with the display. And the end user definitely cannot see 500 frames per second. So it's useless to burn all that processing power to keep updating the screen. So at one point you can basically say, I'm going to wait a little bit until a certain time to continue execution. Okay, I'll give myself, let's say 33, 15 milliseconds. And then in 15 milliseconds, I'll wake up again and I'll resume the logic and update myself. Okay. But as far as the other threads are concerned, this thread, the blue one, doesn't have to be aware of any other threads in execution. Now, if you have a single thread type of model, then we have a bigger problem, because what you need to do is to specify to do something about the blue thread, and then you have to manually specify the logic of the orange part, and then switch back to the blue part, and then switch back to the orange part. So you will be responsible to have to deal with the switching between the various logic of various parts of your application. What if you are adding a green thread now? Okay, so let me pick a green color. So what if your application now wants to talk to a server? So instead of being a single player game, now you want to be able to play with other players. So as far as multi-threading is concerned, it's okay, because you just add another thread that can deal with the server part to interact with a game server, and then use that to update other elements on your screen. But if you use a single thread model, now you have a big problem, because now you also have to change the program to interleave the green portion, interleaving that with the red and the orange portion. Okay, so you can see how a single-threaded model is not exactly flexible when it comes to adding additional components, or even to handle the interaction between components of the same program that are supposed to be concurrent. Okay, so multi-threading is definitely useful. When you have multi-threading, all threads within the same process, they share static resources of the same process. So for instance, in terms of Java, all static members of classes are basically shared, because there's only one copy of those per process, and all threads of the same process have to share those things. Now, each thread has its own stack. Okay, so that part is okay. You can have your own stack, no problem. Threads can also communicate with each other fairly efficiently because you can pass references around because they're still looking at the same memory space. So references work really well amongst threads, which also means because the interface between threads is so flexible and so wide, it also makes corruption possible because now you can have a thread to be halfway done with modifying one particular object, and then the other thread kicks in and go like, okay, I'm going to make some more changes to it, not aware that the object is already being modified halfway by another thread. Okay, so multi-threading opens up lots of possibilities, but it also makes it kind of harder to coordinate things when you need coordination. So you just have to pay attention when we get to that point of coordinating between the threads. All right, so that's the first concept. The second concept is what we call a looper, and if you click on the link here, it brings you to the Android documentation on loopers. And if I magnify one more time, it would actually display you even better. A looper object represents the logic and data structure required to run a message loop. Okay, we talked about the concept of message loop already when we first get into activities. Okay, in other words, if you have a very simple application and it has one single activity, and a button on the screen, so that the user can click the button and it changes some display on the screen. For the most part, the application is just sitting in a loop, but it's not a tight loop, quote unquote. It's not a tight loop. In other words, the loop goes like wait for a message in the message queue. If there is a message in the message queue, then it proceeds to the next point, which is to get that message out of the message queue and send it to the right place to have it processed. And then it goes back to the beginning, which is to wait for another message. Is that making any sense? Okay, so that's what we call a message loop, which is basically to wait for messages and extract messages from the queue and then process the messages. Okay, so those are the three steps, and it keeps doing this indefinitely until you call the quit method of a looper. Okay. And for the most part, what you can do is to look at a looper object as a message queue and the necessary blocking methods to wait for new messages, wake up and ask the right handler to handle any received messages. Okay, that's basically what it is. It's just a queue. You can look at it as a line inside a post office, and you have incoming mail from a truck, and so if the line is empty, the person who is responsible to do all the sorting has nothing to do. But as soon as a message arrives, which means you have a packet on the conveyor belt, the person at the at the head of the line will go like, okay, let me see where I should put this box, okay, and then you have multiple places to put that box for further processing. So that's what a looper is. Okay, the next question now is, how do we associate a thread with a looper? In other words, okay, a thread is an execution point, nothing more and nothing less. Okay, you can specify a thread to do whatever you want it to do by overriding the run method of a thread, which is the starting point of a particular thread. So it doesn't necessarily go into a loop, checking for messages and processing the messages. If you want your thread to process messages, then you have to associate that particular thread with a looper object. Okay, because you're basically saying, okay, worker so and so. You can look at a thread as a worker because it is what the lowest unit of processing that actually does something. So a thread is basically a user. And now the question is, how do you associate a worker inside a factory to say, okay, your responsibility is to watch this conveyor belt. Okay? If something comes along, you have to do some processing with whatever comes along. So that's what this sentence is really about, is how do you associate a worker, basically a thread, with a conveyor belt, which is a looper. Or in more proper terms, a thread can host a looper. In other words, this is just another way to say the same thing. Basically a worker can quote unquote watch a conveyor belt in this case. So to do this, what you need to do is to call looper.prepare, which is a class static method. and that's why it is using uppercase L, because we are referring to the class looper and not referring to a particular object or reference to a particular object. So when you call looper.prepare in the run method of a thread subclass, what it does is it will create, initialize, and also associate a looper object automatically with the thread that is running the run method. Okay, so all of those things will be done by a single call by looper.prepare. This static method, okay, so I just talked about all this stuff here. But one thing that prepare does not do, as the name implies, is it doesn't really get into the message loop itself. It sets up everything, but it doesn't run it. Okay? In other words, you're basically putting the worker next to a conveyor belt and tell the worker to say, okay, when it's time, watch this conveyor belt. Okay? This is your responsibility. But you know what? After prepare returns, the conveyor belt is not running, and the worker can still do other things before doing the processing. Okay? Which is also very important. And I use the word magically associate the looper object with the thread running the prepare method. And there's no explicit new operator in this case. In other words, by calling the class static method prepare, it's implicitly doing the new, implicitly doing the constructor, and also implicitly associating the created looper object with the thread that is running the looper.prepare method itself. Okay? And I call this magically because most of the time, you have to do that with your own logic. Okay, you have to say new object. Okay, here's the reference to a new object. Now we have to say associate this new object to this thread. But this is all done. This is all done for you by the Android framework. You don't have to do a single thing other than just calling the prepare method. Are we doing okay so far with this part? Yep.
Why do they choose to do it this way rather than doing it new of the looper class?
I think it has to do with, this is pretty low level stuff. In other words, the actual implementation of prepare is low level enough that it doesn't want to expose that interface. In other words, it has to do with the low level operation of the Android framework as far as threading is concerned. So it's not something that you can easily do without using this particular method. The other thing is, if it opens up the interface, it may not offer you any flexibility because it's very seldom, if there's any need at all, is to override the class looper. In other words, this is one of those classes where you just use it and you don't need to derive subclasses of a looper.
So is it possible because you would never need two loopers within the same thread?
Well, that's a good question. I have a little FAQ section at the end, so that will answer your question about that one. Okay. Now, as the last part of the run method, looper.loop is called. This is once again, it is a static method of the looper class. It's called to actually run the message get dispatch handle loop of the thread represented by the subclass of that particular thread. Okay, so when you look at the actual code, I'm going to use just a plain text editor to represent what run should look like. So when you have when you look at run, which is I think it's a public method run and is inside a particular thread subclass. Okay, so if you look at the whole thing, this is basically a class, let's say my thread, which extends the superclass thread. Let me change the font size here. It's a little bit too small. There we go. Okay, so when you look at the subclass myThread, which extends thread itself, inside that particular subclass you have to define run as a method, and inside run, what you have to do in this case is to first call among other things, you have to call looper.prepare if this particular thread is to become a part of a message loop. Okay, so what this does is to once again, creates, initializes, and links the looper object to this particular thread, to whatever thread it is running the run method. And then the last thing you need to do is to run looper.loop. And once again, it's a static method, but what it do, is what looper.loop will do is to go to the current thread running this particular method, ask that thread and say, do you have a looper object associated with you? If not, it's an erroneous it's erroneous. Okay, it will throw an exception and say, hey, you don't even have a looper. How can I do a loop without a looper? On the other hand, if there is a looper object associated with this thread, then it will make use of that looper object and actually get into the message loop. In other words, it turns on the conveyor belt, okay, and actually starts to pay attention to the conveyor belt. But until you run looper.loop, the conveyor belt may be prepared, it's existing, it is already allocated, but it's not doing anything. Okay? All right. So the next thing is, what do we do in between? Why do we have to separate these into two separate steps? If there's nothing that needs to be done in between, why not combining these two methods into one single one and say prepare and do it at the same time, right? So this implies that we have to do something in between, and what we need to do in between is to specify handlers for a particular looper. Okay, so now we have another concept called a handler. Now the handler concept is right here. A handler object represents the logic and the data structure that you need to get, dispatch, and handle messages. I actually left out one really important one, which is to send messages also. Okay, so a handler is actually quite useful, okay, because it has it has basically both the sending and also the receiving side of dealing with messages. Okay. All right. Let's go on and try to explain these concepts. A looper object needs to be associated with at least one handler object, because otherwise, who's going to send you messages? Nobody. Who's going to process the message? Nobody. Okay. So in order to send messages, it is a handler object's job. Okay. In order to process messages, it's also the job of a handler object. Okay. So, okay. Let's just move on and see if we can get this concept clarified. Much like a looper object is magically linked to a thread, a handler object is also, and I use italic here, somewhat magically linked with a looper object. The default constructor of handler automatically associates a newly created handler object with the looper object already associated with the thread running the constructor. Now that is quite a mouthful. Okay, so if I switch back to mousepad, I can actually demonstrate that concept a little bit, more convenient. Okay, so let's say that inside this particular class, I have my own private class, and let's say we just call it my handler. Okay. And for the time being, yep.
So every time you create a looper object, a handler object is created as well?
No, it is not automatically created. Okay, so what I'm going to do here is to define my own subclass, my handler, which extends the base class handler here. I'm not going to specify the details just yet, okay, because it's not important at this point. Okay, so what you need to do, okay, or let me just kind of show you the code here. If I just say, okay, I'm going to have another one here, which is private my handler. Handler in lowercase. So just by doing this, handler gets new my handler, and using the default constructor. Okay, just by doing this, it doesn't seem like doing much, right? I mean, this is allocating the storage for a my handler object. It is calling the default constructor of a my handler object, and make handler my private member. A reference to that newly created object. That's all this line seems to be doing. Is that right? Okay, but that's not all the entire story, because the hidden part, the magical part of the story is the default constructor of a handler will also automatically ask the thread that is running this constructor and say, hey, you are the thread that's running this particular subroutine. Do you have a looper? Okay, if you have a looper, I want to be associated with that looper. It will self-register to the looper already associated with the thread running the constructor. So that part is magical because it is not shown here. All we can see here is, okay, handler, which is my private member, is a reference to the new object that is created by the default constructor of my handler. It doesn't seem like it's related to anything else, but it is. Okay, it is it is now associating itself with the looper object, the conveyor belt that is already prepared. It's not running yet, but it is it's now ready to go. Okay. All right. So that also means that in here, inside the private class myHandler, you have to specify the constructor as well. So you have to specify the constructor myHandler as a default constructor. And one of the things, among other things, that you might need to do is to call the superclass's own constructor method. And I think it is super.handler, as a constructor method. So you have to call the superclass's own handler default constructor and say, do whatever you need to do, and I'll do some of the other stuff that I might need to do. Okay? It is this constructor that is magical because it handles the association of the new handler object with the looper object that is already associated with the thread that is running this code. Are there any questions about that particular sentence? Because we now have three concepts. We have the concept of a thread, which is the worker. We have the concept of a looper, which is a conveyor belt. And now we have a new concept, which is called a handler. But a handler, in this case, is actually the more, how should I put it, multi-purpose class, because it is the class that you need to send messages. It is also the class that you need to process messages. In other words, when you have items arriving through the conveyor belt, you pick up the item, so that item is now not associated with the conveyor belt anymore, which is basically the looper. So when you look at the object, okay, the thread that is looking at the object, it's going to say, what am I going to do with this object? Okay, and to specify that logic is the handler's job. Am I doing okay so far with this? Yep.
So the handler accepts messages basically and decides what to do with them.
It does not accept messages, it processes messages. It can also be used to send messages. Okay, let's take a look at the handlers. Oh, okay, I meant to do open window or tab. Okay, so when you look at the class handler, and you look at the methods that it has, okay. So the first one is the constructor, the magical constructor thing. Default constructor associates this handler with the looper for the current thread, which is basically what I'm saying, right? Okay. You can also specify a particular looper, for a handler, but we'll kind of bypass that for now. It has several public methods. It has dispatch message, which is one method that most people do not override. Okay, you can override it if you want to, but very few programs actually need to override dispatch method. And many methods are final too. Okay, if you look at the final method, get looper means you cannot override it. Okay, if a method is labeled final, that means it cannot be overridden anymore. This is it. Am I making that point clear? Okay. So a final method is something that you cannot even override. It's just like, okay, that is it. Now the one method that you want to override is called handle message. This is the message, or this is the method that you must, okay, well, it says right there, subclasses must implement this to receive messages. Okay. So now the question is, who is going to call handle message? Because your job is to specify the logic inside handle message, but not to call handle message explicitly. So who's going to call handle message? Okay, let's take a look at all the things that we have talked about so far. We have the concept of a thread. Okay, a thread is basically a worker. This is the only thing that is representing something, some agent to do the work. Okay, so a thread is a worker. Okay, let's just put in parentheses. This is our worker. A thread is associated with a conveyor belt. Okay, in this type of message handling type of thread. So it has a looper object associated with it. The looper object has no particular name. There's no private member name associated with the looper object, although you can use the method called getLooper within a thread to get back to say, okay, who's my looper? Where's my conveyor belt? Okay, and here it is, a reference to a conveyor belt. The looper object has one method called loop. Okay? And what loop is, is a method that contains, quote unquote, a loop, to basically wait for messages and then to process the messages. Guess what? As a part of loop, it's going to call the handle message, or I should say dispatch message. So it will call dispatch message of a particular handler associated with the looper. Okay? And inside this dispatch message, it will call handle message. That's how you get all the way down to handle message from a thread that is already running. Are we doing okay so far? So what the conveyor belt or what a looper does is actually fairly simple-minded. Its only job is to implement a message queue, okay, a conveyor belt, so that other threads can say, oh, I have something for this thread to do too. Oh, put it on the conveyor belt. It's kind of like at Costco, the person who's working the cashier machine is the thread. That's the actual thing that is processing what is coming through. You can have just imagine a really, really long conveyor belt at Costco. So you can basically have like 20 customers, 20 carts all kind of lined up, okay? And and that's basically what a conveyor belt is, and that's the looper. The person who's the Costco employee is the thread. So the question now is, what is a handler in this case? No, it's not a person because it doesn't do, because it is not an independent thread.
So you're saying, if we're using the whole cashier, then the only thing that's left would be the actual scanner.
It will be an object or something used by the Costco employee.
So it's just a scanner.
It could be a scanner. It could be. It's basically looking at what is coming up, from the conveyor belt, and decide what to do with that thing. Okay. So Costco may not be the best analogy for this. Maybe the post office, okay, mail sorting. So when you have incoming mail, the person at the front of the line has to decide what to do with each particular thing. Okay, so that person is going to have to specify the logic to say, okay, what am I going to do with this particular package? What am I going to do with this particular package? What am I going to do with this particular package? And that's the job of a handler. Are we kind of still doing okay with this? No? Okay. Maybe another picture would do.
It's a little abstract for Monday.
It is abstract. This stuff is abstract, but it is important before we can clear this up. We cannot talk about services because it's based on these concepts. Okay, so what we can do is to think about. Okay, let me just draw the picture here. Okay, so here's a conveyor belt. All right. And the conveyor belt is represented by a looper object. Okay? And with a looper object and a conveyor belt, you can place items on it, okay? And you can pull items out of it. So the conveyor belt goes in one direction, and here we have a worker who's watching the conveyor belt and say, okay, when I get something from the conveyor belt, I'm gonna do something about it, okay? So this is our thread, because a thread is the only active component that can do something. Everything else is a data structure, okay? So in this picture, you kind of have to imagine the conveyor belt is not quote unquote automatic, this person actually has to hand crank it to move it, because remember, the conveyor belt is not automatic. It cannot do things by itself. Some thread has to move the conveyor belt, in order to put items on it or advance items to the next one. And it's really the thread that is cranking the conveyor belt to say, okay, I'm ready for the next item. Is there a next item? Oh, here's the next item. Okay. All right. So is that part okay? With just the thread and the looper.
So the looper is sort of like a queue, right?
Yeah, it is.
Yeah, and okay. And
But it doesn't contain the logic of handling what is on the queue itself. Its only job is to say, give me something. If I put item A, B, and C on this conveyor belt in that order, it will come out from this end as A, B, and C. That is the only thing the conveyor belt is responsible for. Okay, but it doesn't know what A is, doesn't know what B is, doesn't know what C is, and it doesn't know how to handle A, B, or C. Doesn't have the logic to deal with it.
It just knows the name of it.
Hmm?
It just knows the name, essentially.
It just has references to those objects. Okay? Is that part okay in this picture? Okay. So now there's one big question is, first of all, how do we create things to put onto the conveyor belt? And the second thing is, when this thread receives that object at the end of the conveyor belt, how does this thread know what to do with that object? Okay? So it seems like two different questions, right? How do we create object to put onto the conveyor belt? And when the thread receives the object out of the other end of the conveyor belt, what is the thread supposed to do with it? It seems like two different questions, but it has the same answer. Okay? The answer is a handler object. So the handler object is both a quote-unquote factory to create things to put onto the conveyor belt. It is also going to be the instruction for a thread to determine, okay, now that I have this object, what am I going to do with it? Am I doing okay? Yep, go ahead.
So does dispatch message check the object type? That's the message type, and then the handle message handle depending on the message type.
You are very close, but not exactly. Okay. Okay. So what we're going to do here is I'm going to use different colors to represent the type of things that can be on a conveyor belt. Okay. So initially we'll only have one color. Okay. I'm just going to use the orange color here. So what you can do is you can have a handler. Okay. I'm just using handler here. A handler object to basically create, boxes to put onto the conveyor belt. Okay, but it has another worker over here, another thread, potentially the same thread, as this one, but potentially another thread. So another thread can take a hold of the handler object and say, I want to create, an object, a message. Okay. So now the handler object is going to create a message, and you can drop it onto the conveyor belt. Is that okay? Now the color is very important here. As the item gets moved to the forward part here, the thread who is watching this particular conveyor belt will pick up this orange object here. Okay? So after you pick up the orange object, then the thread will go like, okay, who is supposed to handle it? And guess what? This object will specify how to handle this object that this thread is picking up from the conveyor belt. So the thread that is watching the conveyor belt will basically, use the logic specified by the handler, the handle message method, to process the message. Am I doing okay so far? Kind of. So this object is actually shared by whatever thread wants to send the message, and also the thread that is supposed to process the message. The screensaver just kicked in. Yeah, there we go. Because if you look through the public methods of a handler, it has names like handle message, which is very clear of what it is supposed to do, okay? We have a message on our hand right now, okay? Now, whether I got it out of a conveyor belt or whatnot doesn't even matter, okay? The whole point is I have a package now. What am I supposed to do with the package?
Wait, so the handler is sort of, it's a, sort of like what could be done to the message.
What does the message mean, more like?
That's what the message means.
What does the message mean, and yeah, what am I supposed to do with it?
Okay.
Here I have a message, okay? Somebody sent a message, and handle message is basically going to specify the logic of, if I receive a message with these parameters, this is what I need to do.
Okay.
So that means a handler, or I should say, handle message is a method that is specific to a particular handler.
To a specific message or to a specific handler? Is the person who's sending you the message, is he the one that provides the instruction of what to do with the message?
I understand your question, I'm just formulating the answer. The person who's sending you the message can choose the factory to put an item onto the conveyor belt.
Say that again?
Okay, the person who's sending you the message can choose the handler object that is used to create the item. In other words, in this case, I can have, this thread can have access to another handler object that can create yellow packages. And also another handler object in blue to create your blue objects and throw it onto the conveyor belt. Okay?
The objects are messages, or is it?
They're messages.
They're messages.
The small the boxes are your messages. So each
Okay.
one is a message. So this one is a message created by the orange handler. This one is a message created by the yellow handler. And of course, the last one is created by the blue handler object. So they,
Yeah.
go ahead.
No, is there a reference back to
Yes.
which handle created the
Yes.
system? Okay.
Yes, a message knows who created it. Now
Okay.
that's the magical part,
Okay.
because when the worker thread that is supposed to watch the conveyor belt picks up a blue message, then it automatically knows, oh, I need to refer to the blue handler to let it deal with this particular box. Okay, if it picks up a yellow message, then it will go to the yellow handler object and say, I'll let you deal with what needs to be done with this one.
So the handler sort of qualifies the message as to what type of message it does.
That is correct. The color of the message
Yeah.
and its matching handler,
Right.
those go hand in hand.
Okay.
And this thread, in this case, because I can have these three different types of messages on the conveyor belt, that also means that this particular thread needs to have access to those three particular things. So in other words, this thread needs to have a reference all the way back to the blue handler, a reference to the yellow handler, and also to the orange handler. So that basically answered one of your earlier questions. Can we have multiple handlers associated with a particular thread? And the answer is yes. But there's only one conveyor belt. It's just that you can put different items on the conveyor belt.
But so you said you currently said the thread has references to these handlers. So there's only the known handlers to the thread could be the type of messages is only limited to those type of
It should match.
threads
Yes.
that handlers that the thread know about.
Right.
Okay. It's not like someone some other process could come along and formulate a new handler of its
Correct.
own, and then just put it on the looper, and
Yep.
then the thread could take a look at the message and figure out which handler. It's not like that.
I think I have the analogy now for
Yeah.
all of these items. Okay, a thread is a worker, okay,
Yeah.
watching a conveyor belt. A looper is nothing more than just a conveyor belt itself. It doesn't care what is on the conveyor belt. Its only job is to move the stuff around, right?
Yeah.
Okay, is to implement a queue so that multiple things can put stuff on the conveyor belt, and it will be processed one by one using a FIFO first in first out order. But I know what would represent a handler. Okay, a handler, if you think about it, is the instruction related to a particular type of material that you can send by mail. Okay, so we can have hazmat, hazardous material. So there's instruction related to how to package and label hazardous material from the consumer perspective, the sender's perspective. But from the postman's perspective, it has procedures also related to how do I deal with hazardous material. Okay, so hazardous material is basically quote unquote the handler because it includes the logic to package it and put it onto the conveyor belt, as well as the logic to pick it up from the conveyor belt and say, okay, now what do I do with this? Okay, and another handler would be, let's say, we have hazmat, fragile material. Okay, so if you go to the USPS website, they probably have instructions of how to package fragile material and what label to put on it. How do we let people know it's fragile material? So just hold on one second. Okay, so the person who's at the end of the conveyor belt will pick up something that is labeled as fragile material, and it will follow the proper instructions to handle and process the fragile material. Yep, go ahead.
Never label as fragile.
Because they will throw it harder. They'll put it at the bottom of the pile. So is that kind of working?
Yeah, my main question was,
Mhm.
okay, could any message other than the subset that the thread knows about,
Mm-hmm.
any other, could I put onto
You cannot.
conveyor belt a message that has a different handler?
Nope, you cannot.
That the
Because
thread does not know about.
okay, here's the trick. You cannot. Because as far as the sender is concerned, the sender only has access to the handler objects. But the handler object also knows which conveyor belt it is associated with. So when you use a handler object and say, hey, handler H, I want to use you to send a message, it already knows which conveyor belt it's supposed to go to. So you cannot send a wrong type of message to a conveyor belt that the worker doesn't know what to do with it. Okay, so the whole thing is all linked already because each handler object is already linked with a particular conveyor belt. So and then the other thread, the thread that is sending the message, can only use the handler object to send a message. So that automatically sends the message to the right conveyor belt, to the right looper object. And then the looper object also knows which thread is associated with it. So we know the whole thing is kind of closed. There's really no room for error other than programmatic error of you forgot to specify how to handle a particular type of message.
Okay. So, for example, if there's two different threads with two different looper, there's only one-to-one association between looper and thread, right?
That is correct. One thread can only have up to one looper. You can have your general thread which does not do any looper thing. That's up to you. But if you want to associate a looper with a particular thread, you can only have one conveyor belt.
And there could be more than one handle associated with looper,
Yes.
but a handle cannot be associated with more than one looper.
That is correct. So that means in this case, if I have multiple things to deal with, I can have my handler 1, okay, and I can have my handler 2, like that.
Yeah.
And then inside, I would now have handler 1 is my handler 1, new my handler 1, and then handler 2 is new my own handler two, like that. And of course, my private member now needs to have, my handler one dealing with my handler one. And this really, should not be private. Well, okay, you might make it private, but later on use other ways to expose the handler, because whoever is going to send you messages also need to know that particular handler, because each handler object is including the instructions of how to create those messages. So in this case, I would have, the same thing, except it's private, my handler two, and so on.
So the dispatch message is for sending, and then handle message is for the receiving part.
Say it again?
The dispatch message is for sending the message into putting the message into
To
the
send
loop.
a message has send messages. So if you look all the way down here, it has send message to actually send a message.
Okay, to put the message onto the looper.
Correct.
Okay.
So send message is the action usually done by by any thread. Doesn't have to be the thread that is actually operating the conveyor belt, but send message can be used by any thread in order to create, it's not responsible to create a message, but it is responsible to put it onto the conveyor belt. And then the looper is responsible to move that message along, eventually getting to the thread that is processing the things on the conveyor belt. And then handle message is the logic of looking at a particular packet that you just retrieved from the conveyor belt and say, what am I going to do with this?
Okay, the handle message actually processes the message.
Correct.
But how about, I'm not clear of the dispatch message.
Dispatch message?
Yeah, what's
Okay.
the function?
The function of dispatch messages is a little bit interesting, because everything that you receive on the conveyor belt is quote unquote a message, but some of those are not actual messages. Okay, let me show you one thing that is not an actual message. It's whenever you use post, you're putting a quote unquote a runnable on the conveyor belt. A runnable is not a message. In other words, it's not handled by a handle message method. A runnable is nothing more than code that can be run, and it is just it's just a mechanism of scheduling who is going to run that code and when that code is going to be run. So that's the whole purpose of using post or the entire family of post is to specify quote unquote arbitrary code that can be run by this particular worker thread. Okay, it has one single method called run, lowercase run, open paren, close paren, and whenever this worker, the Costco employee or the post office employee, picks up that particular quote unquote message, the packet, it would just be like, okay, this is not a message. It actually contains the actual code for me to run. So it would just run it when it receives it.
Is this runnable object put onto the looper as well?
Yes, it is. It's put onto the looper along with other messages. Yeah. So when you look at your items on the conveyor belt, it can have runnables, which is done by post. It can also have messages, which is done by send message. Now, when you have a post, because a post method is also associated with a handler, so that means whenever that post method is run, it's also run by a particular handler. And the way I specify the code here is slightly incorrect because I make the class private, but it cannot be private because other people also need to have access to my internal class here. So this really cannot be private. It has to be public because the class itself has to be exposed to other threads, potentially other threads, so that they can send messages to me.
These other threads could be in other processes as well.
No, they have to be in the same process. They have to be in the same process. If you're talking about in other processes, then you're talking about surfaces. So there's another layer of mechanism involved. This is the lowest level of stuff involved in the same process in order for one part of your process to communicate with another part of the process. Okay? Right, those are all very good questions. Are there any other questions related to what we are talking about here? Have we seen anything like this before? Or have we made use of something like this before? Before as in for the first part of the entire semester. Activities. How do you think activities and all the other stuff related to activities relate to what we are talking about here?
Updating the screen. Updating the screen.
Updating the screen. Now, whose job is it to update the screen? That particular thread has a name from the previous lecture. Say again?
UI.
The UI thread or the main thread, okay? So in that case, this thread here, the little matchstick figure, is what we call the UI thread or the main thread, which is basically the first thread that is created for any particular application, okay? And what would be on the conveyor belt in that case? And who's going to put stuff on the conveyor belt in the case of an activity? Okay, let's go ahead and redraw this picture. Can I erase this part? Because we start with a thread. The thread has a looper object. Inside the looper object, it has its own method to do a loop. And then inside the loop method, it will basically go through a loop to get messages out of the conveyor belt and dispatch it. Now, in dispatch message, it will check whether it's a runnable. If it's a runnable, it will just run it. If it's not a runnable, then it will call handle message to basically say, okay, you deal with it. Okay, you have to find out what to do with this particular message. A message is a very short thing. It's just like 2, 5. Okay, well, what does it mean when I get a message of 2? Only you know. Okay, so I'm gonna erase this part. Now let's take a look at how this concept relate to what we have already done using activities and so on.
So messages are always going to be really short?
Sorry?
Small pieces of data messages?
Right, messages are very short. If you look at the type of a message, it's very short, and you can only put like a few things inside the message. So let me take a look. Send message. So if you look at the message type itself, it's a pretty short little thing. It doesn't do a whole lot. It defines a message containing a description and arbitrary data object that can be sent, which can be very short. So when you look at a field inside the message, it has argument 1, argument 2. It has a reference to any object, just obj. It knows the messenger, optional messenger where reply to this message can be sent. So it gives you like a two-way thing. You can actually reply to a message, and that's it. It's a very simple, short little thing. Okay.
Because it's just calling a reference.
Correct.
Yeah.
Or in most cases, you can leave the reference to the object null and just say 5. Okay. Well, the handler object itself knows what to do with a message of 5. Okay. Oh, message of 5 means I need to do this.
Blow it up.
Or yeah, whatever. Right? So it can be very short because it's just an indication of somebody is asking you to do blah. Okay? So it's up to you to interpret what 5 means or what 2 means and so on. All right, so let's go back to activities and see how this whole thing relates to what we are talking about. We still have a conveyor belt. We still have a worker at the end of this conveyor belt and it's moving in this direction. But this time, this is not just any thread, this is our UI thread, which is the main thread of a particular application. In any type of application that has an activity or something to do user interaction, this is the only thread that is supposed to do anything about screen-related or user input-related type of operations. Okay? So the question now is, what kind of stuff can we put onto the conveyor belt, and who is going to put stuff on this conveyor belt? Okay. In other words, I have stuff on the conveyor belt. The question is, who is this thread that is putting stuff on the conveyor belt? Think about what kind of message or what kind of trigger, what kind of operation your UI thread is supposed to do with an activity. Let's go take a look at one of the past examples that we have done. And we can test, test menu would actually work fairly well here. If you look at test menu, If you remember, what that was all about, we have layout and look at the fragment. Okay. And let's see if we can just run it. Okay.
Did you forget to set up your AVDs when you fixed your installation?
Yep, something like that. Okay. But keep thinking about that question, okay? Who is going to put packages onto that conveyor belt as far as the UI thread is concerned? The UI thread, the only job of the UI thread in this case is to deal with what? Messages. Things that are related to the user, right? That's the name. That's why it has the name of user interaction, UI. Okay. So let's go. Oh, okay. I think it just stopped by itself. It broke. Okay. But as the name implies, what do you think test menu? What type of user interaction can I do with a program called test menu?
Press the menu.
I can have a menu item, right? You can click on the menu item. All right. Well, what happens when a user clicks on a menu item? It runs the appropriate code, on menu clicked, or on menu selected, right? But how did it get there? That's the question.
It detected a touch.
It detected a touch, but who is?
Responded to.
But it okay, yes, okay. The UI thread corresponding to your application is responding to a menu item being clicked. Okay, that's the conveyor belt item. That's the item. Okay, so whenever the user selects and click on a particular menu item, somehow on this end, from your application's perspective, it picks up a box and say, oh, somebody just clicked this item. Let's see who's going to process it. Oh, you're supposed to process it. Okay, but the question that I had was who put that box into the conveyor belt to begin with? It is not your own thread, is it? Okay, it doesn't work that way. Your thread was sleeping. That worker is dozing off the whole time until something appears on the conveyor belt. So who put that item onto the conveyor belt? The Android framework. Okay, so that's outside of your application. The Android framework is actually the one that is putting the box onto the conveyor belt. Is that making any sense? Yep.
Would it be possible for you to add a message?
You as in who?
As
Sorry.
in the programmer themselves.
Yes, you can. Okay, and in fact we do. Okay, and we also do that too. Okay, look, if you just look at this application here, it's like, how can this application get any simpler? It cannot, right? Okay, so the next question now is, when I click on a particular item here, okay, when you look at the activity class has it close menu, get menu inflator, invalidate, on context item selected, on context menu closed. Basically, all of these on something, they are here to respond to something. In other words, these are the things that your that the implicit hidden handle message is calling. Okay? It's just that they're predefined here so that you can easily override these things and figure out what to do. But I'm looking for a particular one, so let me just search for that one first. Okay, I'm gonna menu item. Okay, let me search for that. Menu item. Okay, there we go. Okay, let's take a look at this method here. Default implementation of on menu item selected, blah blah blah, and this calls this calls through to the new on option menu items options item selected method for blah blah blah. The change of the name has to do with we go from the concept of menu to the concept of an action bar. So, but regardless, okay, this is a handler. Okay, this is basically defining the logic of saying, okay, somebody just selected this menu item here. Do something about it. Okay, or I should be more specific and say that some menu item is selected. Okay, and this method is called to say do something about it. Okay, you can choose not to do something about it and just say, okay, it's handled, return true. Okay, fine. Or you can choose to do a lot of work, and that work is done by the UI thread. Okay, are we still okay with this? So what if the user, okay, what if one of the menu items says change hello world to hello kitty? So I want to change the text view from hello world to hello kitty in order to respond to a particular item being selected in the menu. So what do? You override this method, right? And then you say, okay, if this particular menu item, which is passed as a parameter, is clicked, then what I want to do is to update the text view content and use the set text method of the text view item and say, I want to update the content to hello kitty. Okay, what does that actually do? Think about the set text method of a text view inside a particular activity. What happens when you call set text? Okay, let me just pop up that window too, so we know what we are talking about. So we are looking at the Android class called text view, and inside text view it has a whole bunch of set text methods. But we are looking at a particular one that is as simple as it gets. And the one that we want to look at is
set text.
text char sequence. This is the one. Okay. This is the set text method. Set the string value of the text view. Text view does not accept HTML-like formatting, which you can do with text strings in XML resources. The style of strings, okay, and so on. Seems like it's a simple thing. We look at the text of a text view and say we want to change it. Do you guys remember one thing? Remember when we did the rock, paper, scissors example? We used text view, and when we step over text view, the actual text inside the activity did not change right away. So what do you think happens when we use set text? Yep. So in that particular case, UI thread, okay, is going to go through all the trouble, okay, to get to on menu item selected. Okay, are we doing okay so far? So it goes through a lot of logic to get to this part. This part eventually will go to the set text method of a text view, okay? And set text is going to call invalidate at some point to basically say, you know what I'm displaying here on screen is no longer the actual content, okay? So maybe it's not calling invalidate because I think invalidate will automatically withdraw the screen right now. But what it does is it's going to send a message or post something, and it will put another item back onto the conveyor belt, so that this item, new item says, okay, you know what? I just changed the text of this text view. It needs to be redrawn, but it's not redrawn right away because it is just placing the request to redraw that item onto the conveyor belt. So until this item of the conveyor belt gets to the front and be handled by the UI thread, what it displays on the screen stays the same. Is that
So that message would be in the Android architecture and be some code that it understands to redraw just a couple numbers?
correct? So you're basically just using set text, but inside set text as a method, it is actually using either a send message or a post to specify what to do in order to update that item on screen. But that is all hidden from you so that you don't have to deal with the low-level detail of either posting a runnable or or sending a message, the appropriate message. It is all done automatically for you. So the entire handler in this case is hidden from you. You have no idea what is the handler that is actually responsible to form the packet to put onto the conveyor belt or to dispatch the thing to the right place to have it handled. Is that making any sense? So all along in this semester, we have been using the concept of this conveyor belt and also handling messages, except that we don't have to deal with the details because it is all hidden away from us, because those are the things that need to happen frequently, and the Android framework, just has built-in methods to deal with all of those stuff.
So, an application already has a UI thread, and
Okay.
it will already have a looper in there. And then so, that, like you said, is handled by Android for us. And then so when we create other threads, we have to deal with that ourselves.
When you create other threads, okay, the question is, who is doing the processing? Okay. Now, if all the processing is done by the UI thread, then all of the other threads, need to ask the UI thread, put items onto the conveyor belt, so that the UI thread or the main thread is the one that is actually going through the motion of doing all the processing. Okay.
Okay, for handling messages, but you could put onto the looper non-message types.
Runnables. Yes, you can post.
Okay. So if you want to tell a different thread to do something, do this.
That is correct. Remember what we did last time? Remember, on last Wednesday, we wrote a program that updated, like the number of seconds on screen, 1, 2, 3, 4. Let's go back to that program because it is also closely related to what we are talking about now. So let's go back to that program, and it is called test thread or test threads. I think it's this one here. The source. Yep, it is this one. Look at this call here, the one that I have just highlighted. Run on UI thread R, and what is R? Okay, so you track, all the way back to, exactly what is R. R is a runnable. And how is R created? When we look at the constructor of onCreate, R is created from what to do as a class, and what to do as a class is here. And what run does is to specify, go to a particular view and display, a number on it. That's all it's going to do. This call here, okay, A is the activity, and then run on UI thread. That's basically a post. It's posting a runnable or adding a runnable object onto the conveyor belt. And the conveyor belt, it belongs to the UI thread. So that's why, my thread, this is not the UI thread because I'm doing this. I'm doing a post from my own thread, which is another person interacting with the conveyor belt. Okay, so in this case, you can look at my thread as another worker. It's not the system, it's not the Android system. This is a thread that I purposely created. But that thing can put another item onto the conveyor belt known as a runnable. But eventually the runnable is going to reach the UI thread. The UI thread will pick it up and say, oh, this is not a quote-unquote normal message. It is actually a runnable. So then it will pick up the code inside the runnable, inside the run method, and actually run it. So that means, whoever is putting, there are many people, many threads can put items onto the conveyor belt, including the thread itself, the UI thread itself, because you can see that in this case, the set text is going to put an item onto the conveyor belt. In other words, in this case, we can look at it as note to self, right? You're putting a note to self onto the conveyor belt so that, when that note to self, becomes the current item, you just look at it and go like, oh, that's right, I was reminding myself, to do blah, blah, blah. Okay.
Let's confirm my understanding. So in Android, your application is just a thread within the Android framework.
Okay, there are
And
the Android, when I
framework
refer,
is just a single process.
it may be one, maybe multiple. Okay, it's just something out of your thread. Those are threads managed by the by the Android framework system, which can be a single thread, can be multiple threads.
Yeah.
We don't really care how many threads there are outside of your application. We know one thing. They all know your activity, and inside your activity is a handler that specifies how to put items onto your conveyor belt. That is exposed to the Android framework because when someone clicks something, when someone clicks a button, the Android framework needs to know how to put that item onto your conveyor belt so that your application or your own thread eventually will have to handle it. Go like, okay, somebody just clicked this here, handle it, deal with it.
Let me just ask a question. So your application is a thread within the Android framework.
Your application is a process. Okay,
It's a
when you
process.
run your application, when you click on your application, it becomes a process. And as a process, it has at least one thread, and that particular thread is known as the UI thread or the main thread because it's the first one. Okay? That one by default is a looper already. So it's all set up for you. You don't have to deal with loopers at all. And that's why until now, we don't even know there's a looper involved in all of the stuff that we have done in this entire up to this point in the semester.
Yeah, I'm just trying to understand when we say Android framework, what does that exactly mean?
When I
Is it
refer to
like-
the Android framework, at runtime, it means whatever threads, whatever processes that the Android system needs to run in order to keep your Android mobile device working. So anything excluding your own thread of your own application, I refer to all of that as a part of the Android framework.
So when you touch your screen,
Mm-hmm.
the Android framework somehow create a message to send into your process.
Yep.
So is it crossing a process boundary when it is sent to your application? Is it crossing a process boundary?
That's an interesting notion. Okay. Okay, so here we go back to the manifest file. Okay. What do you specify in the manifest file inside an Android application so that the Android framework knows how to start your program? Quote unquote, how to start your program. Let's take a look. So we go to, I think it's inside resources. Look, right here, Android manifest. So when we look at this file, what is it specify? Let's go to the text
What do you mean by
representation.
process boundary?
Well, I'm trying to understand that myself. Is it whether there's a different mechanism to communicate between processes versus between threads, right?
Okay. Now, when an application is started by the Android system, the first thing it does is to look at the Android manifest file. Is that okay? So inside the manifest file, the first thing that is identified is the package. And a package uniquely identifies where your application is located. Okay? So this will basically let the Android framework, which is the operating system, know where your program is. Now inside your program, you have other resources as well, and the other resources includes layout, and part of the layout is activity. Okay, and inside activity, when you look at the XML file itself, do you see something that is a class name?
Is what?
That is the name of a class?
No. Oh wait, video.
Isn't that the name of a class? And that's how the Android framework or the operating system knows what to create, because it's coming from here. So the Android framework will do several things. One of the things that it does is it will create a thread in order to run your program. In fact, it will create a process to run your program. So you are correct that your program is not in the same process as the Android framework itself. It is its own separate process. However, there is a way to cross that quote-unquote boundary between processes in order to send something to you. It's called Inter-Process Communication, IPC, and the mechanism that is involved here is called RPC, or Remote Procedure Call. And that's how the Android framework, which belongs to a different process, can send messages and put it onto your queue, put it onto your looper that you can process eventually. Okay, but you are moving quite a bit ahead of me, because that is the concept of talking across processes and putting something onto the looper of another a thread of another process is actually a little bit more complicated, because it involves a little bit more coordination compared to what we have been talking about so far. So what we need to know at this point is the framework, the Android framework, does have access to your stuff. It has access to your conveyor belt. So whenever someone clicks an item on the screen and an event is generated, the Android framework can just drop a package on your conveyor belt and say, okay, something happened, here you go. And then that item will eventually move up the conveyor belt until your UI thread gets a hold of it. When the UI thread gets a hold of it, it has its own handler to deal with all the UI related stuff. And eventually, the message will get dispatched. Now, the only reason why you don't have to write your own handle message method is because it's already done by activity. So which also means when you look at activity itself, okay, it has its own handler already. Okay, let me change this. Inherited methods. Somewhere in here is a way to retrieve your own handler object responsible to handle the messages coming from the system. It's inherited because when you look at the hierarchy of an activity, it's actually pretty low already. So it starts with an object, and then you have a context wrapper, context theme wrapper, and then you get to the activity. So by the time you get here, it has the handler already specified.
Back to my question about dispatch messages. That is just to remove the message off the looper. That's
Nope.
it? No, I'm still not clear on.
By the time you get to dispatch message, the package is already removed from the looper.
Okay.
You're already looking at it. The only reason why you have dispatch message as opposed to handle message is because there are two main types of messages. One is called a runnable, and the other one is a general purpose message. If it's a runnable, dispatch message will just run the runnable right away. It's like, okay, do it, okay, and there's nothing else to do. If it is a general message, then it will pass it on to handle message, where you will have to override handle message and actually look at the constants, the ints and stuff like that, and say, okay, what am I supposed to do with this message? Then you have to use your own code to specify, when I see this integer arg1, arg1 is a 1, this is what I need to do. When this integer is 2, this is what I need to do. So that's why it is custom, because because each handler is different. It can handle the messages differently. Whereas if it is a runnable, there's not much you can do about it. It's just, okay, it comes with a runnable, let's just run it.
It seems like the only difference is with runnable, there's maybe no parameter, and with a message, it's essentially the message is a parameter.
No. Okay, the main difference is a runnable, what you run in a runnable is determined by whoever puts that message on your looper, on your conveyor belt. When it comes to a regular message, what you do about a certain message is up to your own handler to determine what to do with it. Okay, so for things that you cannot possibly anticipate and say, oh, okay, whoever sent me messages may want to do this, may want to do that, may want to do this, you want it to be a runnable. For things that you can predict and say that, okay, my job is to do da da da, there are only 5 things that I'm supposed to do, and people who ask me to do things have to be one of these 5 things, then it falls into the general message category, because there are only 5 types of messages you can possibly process. So it may make sense to put it into the handle message method instead of having it become a runnable, where whoever drops the package onto the conveyor belt has to specify exactly what you are supposed to do. I mean, you're supposed to know what you're supposed to do. The difference, is, why do we even need runnables in some cases? It has to do with the example that we did last Wednesday actually illustrates that. So when you look at, am I looking at the right project here? Test thread, yep, it's the right project. So when you look at this particular project, this is a runnable. And when you look at what to do here, when you look at this code here, that is just displaying an integer in a particular text view item. But from the perspective of a general activity, how can it know that you want to display a particular integer value in a particular text view? It doesn't know. I mean, this is something that is outside of what a activity is supposed to do, right? So that's why you specify as a runnable and say, okay, when you get to this package here, just run this code and update that particular text view with this particular integer, and that's it. Okay. Are there any other questions about what we talked about today? I mean, are those concepts okay, or do you guys want me to kind of use a slightly different way of presenting those concepts? Okay, so now we have another, I will leave today's class with one question, okay, and we'll deal with that question on Wednesday. A regular UI thread, most people look at UI, as a user interface and say, okay, a UI thread has one responsibility, to handle clicks, to handle, menu items getting selected, to update the screen and stuff like that, okay, which is all correct, okay. So here's the next question. Can a particular UI thread, can it also act as a service? In other words, it's not just responding to what a user is doing to it, it can also answer to other applications running in the system and say, oh, so you want me to go to that web page? Yeah, I can do that. So the question is, can it also handle other applications asking it to do something? Think about WebKit, the browser. Okay? And think about what we have done in App Inventor, which is to use a particular application, your app, to ask another app to say, go to that URL. I want to show that web page right now. Okay? So that means you can also make your UI thread not only to respond to user interaction related stuff, but also services that you have registered. In other words, you can basically register with the Android system and say, if someone needs to do blah blah blah, I'm the person who can do it. Okay? And if nobody is asking you to do it, hey, nothing happens. But if other applications is saying, oh, I need to do this, okay, as quote unquote what we call an intent, and you register with a system that you are someone who can do that, the operating system can act as a middleman and say, hey, you know what? This app wants to do XYZ, and you just register with the system that you can do XYZ. I'm going to pass that request on to you and say, okay, this app wants to do XYZ, you're going to handle it. That's called a service, okay? And we'll deal with that on Wednesday, okay? Because the same thread, the same UI thread can also deal with it, because the ability to deal with it has to do with it can have multiple handlers. So you have one handler corresponding to user interface type of thing, and you have another handler dealing with services. And that's how you can have one single thread to basically to deal with multiple things. Like you have one person at the end of a conveyor belt in the post office that can handle both fragile items as well as hazardous material stuff. Okay, because there are two different handlers in that case associated with the same conveyor belt. So that's what we'll do in the next class. Is to take a look at surfaces and see how we can extend our quote unquote usual program to also deal with that. Okay, are there any questions? The analogy works well, except for the concept of a handler. Thread, no problem. The looper, not a problem. But the handler is a kind of problematic thing because the name handler is somewhat of a misnomer because it's not just handling messages, but it's also used to create messages to begin with. So it's not really exactly just a handler. It's also a factory of what needs to be handled. All right, so if there are no questions, I'm going to stop the lecture today. And then if you guys have any further questions, I can answer those questions now. How was the project? Now it's past due.
It's actually 11:55 today.
Oh, is it?
Yeah.
Oh, okay, so you guys can still work on it. Who's still working on it?
Scared me for a second.
You don't have to answer, but who's working on it now?